Okay, so are you curious at all about how the water industry has been handling these viruses like SARS-CoV-2? We've got this really interesting editorial from some real experts in the field. It was published in Science Water Research and Technology back in 2020. And it basically asks this pretty important question. Will SARS-CoV-2 like reset the public health requirements that we have in the water industry? But this deep dive isn't just about COVID-19, though. It's really about how prepared our water systems are for any new virus that could come along?
Yeah, one of the things that really struck me about this whole situation was how quickly the water industry responded. Back in early 2020, there was so much we didn't know. But even then, you saw these monitoring programs popping up all over the world. Like the Water Research Foundation even held a virtual summit that was dedicated to figuring out how to best track the virus, out in the environment.
That's pretty impressive, right? It
Yeah.
seems like they were ready to just tackle the problem head on.
Absolutely. And I think a big reason they were able to do that was because they had all this research from previous outbreaks, like SARS, MERS, even Ebola. So they weren't starting from scratch, really.
So they're able to apply the lessons that they had learned. That makes sense. But how are they actually like tracking the virus, in the water?
Well, they're tracking SARS-CoV-2 RNA in the wastewater. It's a pretty smart approach, actually. It gives us a sense of how widespread the virus is in a community. And not only that, it even helps us figure out how well our treatment systems are actually removing it.
Okay, so wastewater monitoring is a big part of this. But what does that tell us about public health? Why is that so important?
Well, it's kind of like having this window into the health of a community. By analyzing wastewater, researchers can get this real-time snapshot of how much virus is out there. And the really cool part is they can do this before people even show symptoms or get tested. So it's like an early warning system.
Wow, that's incredible. But thinking about this brings up another concern, especially when we're thinking about recycled water. How can we be sure that our drinking water is safe, especially in those systems that use recycled water?
Yeah, that's where this thing called quantitative microbial risk assessment comes in, or QMRA for short. It's a scientific process that helps us understand and manage the risks that are associated with microbes in our water.
QMRA, that sounds pretty complex.
What can be, but at its core, it's really about figuring out what's an acceptable level of risk and then designing treatment systems that can meet those standards. So when we're talking about potable reuse, which is where we treat wastewater to the point where it meets drinking water standards, QMRA helps ensure that that recycled water is actually safe to drink.
So it sounds like QMRA is really crucial for making sure that recycled water is safe and that it meets those strict drinking water standards that we have.
Exactly. And when it comes to a virus like SARS-CoV-2, QMRA basically boils down to looking at three main factors.
Okay, I'm all ears. What are those three factors?
Well, the first one is the concentration of infectious pathogens in the source water. In this case, we're talking about wastewater.
Yeah, that makes sense. The more virus there is in the wastewater, the higher the risk, right?
Right. But here's the thing. Research is showing that the concentrations of SARS-CoV-2 in wastewater are generally lower than, or at least comparable to, other enteric viruses. And those viruses are already regulated. The regulations we have now for potable reuse are actually based on the highest reported concentrations of those other viruses. So it's super conservative.
So even though SARS-CoV-2 is a new virus, it sounds like our current regulations are already set up to handle even higher levels of other viruses.
Exactly. And there's another wrinkle here. The molecular methods they use to detect the virus in wastewater, like techniques like RT-qPCR, they can't actually tell the difference between infectious viruses and those that have been inactivated.
So we might be seeing a lot of viral RNA, but it doesn't necessarily mean that it's all capable of causing infections.
Exactly. It's an important point to remember. And to really dig into that, we need to look at what the clinical research is telling us.
All right, so let's dive into that clinical research. What can we learn from that?
So we do find SARS-CoV-2 in fecal matter, but there's a lot of research that hasn't actually been able to isolate, those infectious virus particles from stool samples. And there's some evidence suggesting that it gets deactivated pretty quickly, in the gut.
So even though we see it in the wastewater, the actual risk of infection from it might be lower than we initially thought.
Exactly. And that kind of all feeds back into, understanding that first factor we were talking about, the concentration of infectious pathogens in the water.
Yeah.
So let's move on to that second factor in our risk assessment, the effectiveness of the treatment barriers we have in place.
Right, the treatment barriers. So this is where those water treatment plants really got to prove their worth. How good are they at removing or inactivating this virus?
Well, the interesting thing here is that the structure of SARS-CoV-2 actually makes it easier to deal with. Unlike some of the tougher viruses out there, SARS-CoV-2 has what we call a lipid envelope. and that makes it much more fragile and easier to inactivate during treatment.
So it's not as tough as it seems then.
Not really, no. It's kind of like the difference between like a hard candy shell and a delicate piece of chocolate. One is going to hold up way better under pressure.
Okay, I like that analogy. So give us some examples then of the treatment processes that are really effective against this, chocolate
Well,
virus.
chlorine inactivation is a big one. Studies are suggesting that SARS-CoV-2 is probably even more susceptible to chlorine than Ebola. And we know that Ebola can be inactivated with very low chlorine levels.
Wow, that's really good to know. What about UV disinfection? Does that play a role here too?
Oh, absolutely. SARS-CoV-2 has an RNA genome, which makes it really susceptible to UV light. And a lot of the potable reuse systems that are out there already use high doses of UV as part of their treatment.
So that's two really effective methods right there. Chlorine and UV. Are there any other processes that are important in this context?
For sure. Another thing is that SARS-CoV-2 is relatively large compared to other viruses, and that size makes it easier to remove through physical processes, like filtration. It's kind of like using a sieve. And this kind of filtration happens both in conventional wastewater treatment and in the more advanced systems that use membranes.
So it's like this triple threat then, chlorine, UV, and filtration all working against the virus. It sounds like our treatment plans are pretty well equipped to handle it.
Yeah, that's a good way to put it. And this brings us to that third and final factor that we look at when we assess risk: infectivity.
Okay, infectivity. So this is all about, how likely it is that someone would get sick from the virus if it was present.
Exactly. And to be honest here, we have to acknowledge that there's still some uncertainty. We're not totally sure if SARS-CoV-2 can even be transmitted through drinking water.
Hmm, that's a pretty big unknown. But even if it could be transmitted that way, wouldn't the chances of actually getting infected be really small?
That's what the research seems to suggest. Remember we talked about rotavirus before? It's a really infectious virus that we use as a benchmark when we're developing regulations.
Hmm.
So even if we assume that SARS-CoV-2 could be transmitted through water, the likelihood that it would actually cause an infection is probably much lower than
Yeah.
rotavirus.
So let me get this straight. We've talked about how SARS-CoV-2 is present at lower concentrations in wastewater. It's also more vulnerable to those treatment methods, and it's probably less infectious even if it was in drinking water. Is that about right?
Yeah, you got it.
Well, that definitely makes me feel a little bit better about turning on the tap.
It's good to be informed, but it's also good to remember that the systems we have in place are working.
And that those scientists and researchers are constantly learning and adapting. This deep dive has been really eye-opening. It's given me a whole new appreciation for, everything that happens behind the scenes to make sure that our water is safe. But I'm curious, what are the authors' main takeaways from all of this? Do they think that we're out of the woods when it comes to threats from viruses in our water?
I think they would say that more research is always needed,
Yeah.
especially with a new virus like this, but they seem cautiously optimistic. They think that the safeguards we already have in place might be enough.
Cautiously optimistic. I like that. Hopeful, but not ignoring potential problems. What kind of recommendations do they make?
They really stress the need for the industry to keep learning from past research. Both on those similar coronaviruses and on this new research coming out about SARS-CoV-2. They're really calling for a thorough evaluation of its potential impact on water systems.
So basically, keep learning, keep researching, and refine our understanding.
Yeah, exactly. And they also point to some positive stuff that's already happening. Like, for example, there's this really cool work being done in California right now. They're trying to figure out, what the potential impact of SARS-CoV-2 would be on treatment requirements for direct potable reuse.
Direct potable reuse, that's where they add the treated wastewater directly back into the drinking water supply, right? Like taking water recycling to a whole other level.
Exactly. California is really leading the way when it comes to potable reuse. And they're being super proactive to make sure that SARS-CoV-2 doesn't cause any problems.
So they're gathering data and analyzing trends to try to stay ahead of the game.
Yep, that's the idea. They're being really thorough and using science to guide their choices.
That's good to hear. But even if SARS-CoV-2 itself isn't this huge threat to our water systems, what about other viruses? The ones that we haven't even seen yet. How can we even be ready for those?
That's a great question. And it really gets at the final thought in the editorial. Their argument is that those robust treatment systems we have, those multi-barrier systems, they weren't designed to target one specific virus. They were built to handle a whole bunch of different waterborne pathogens.
So instead of trying to guess what the future holds, they're saying we need to make a system that's flexible enough to handle anything.
Exactly. It's all about designing water treatment that can deal with all kinds of pathogens. even the ones we don't know about yet.
So like building a fortress that can withstand any attack, not just one specific kind of weapon.
Exactly.
So how do we actually do that? How do we make our water systems more resilient?
Well, it takes a bunch of different approaches. We need to invest in research to come up with new treatment technologies. We need to make our monitoring programs better. And I think the most important thing is that we need better collaboration between scientists, engineers, and public health officials.
So it's about working together and sharing knowledge, trying to stay ahead of those challenges.
Exactly. Being proactive instead of reactive.
This has given me a lot to think about. We've covered so much, like how quickly the industry responded to the pandemic and the amazing ways we can track those viruses in wastewater
Yeah.
and QMRA and all those different layers that protect our drinking water. It's been a really cool look at the world of water science.
And honestly, we've just scratched the surface. There's so much more to learn. But I think it's safe to say we can all raise a glass of water
Yeah.
to all those scientists, engineers, and public health folks working to keep our water safe.
Absolutely. Cheers to that. And to everyone listening, thanks for joining us for this deep dive into water science. We hope you enjoyed it. Stay curious, stay informed, and stay hydrated.